To effectively design and install whole home solar systems, several resources can provide valuable information. Firstly, let's explore some helpful books. Solar Power Your Home for Dummies provides a general introduction to the topic. Solar Electric Systems Design and Installation offers a more in-depth look at system design. Off-Grid Solar Power Systems for Beginners focuses on the specifics of off-grid applications. The New Solar Home explores modern solar home design. Sustainable Home Energy, a comprehensive guide to renewable energy technologies and green building measures, covers a broad range of sustainable energy topics. Secondly, various websites offer useful information and resources. The National Renewable Energy Laboratory (NREL) provides research data and technical information. The Interstate Renewable Energy Council (IRC) offers resources on renewable energy policy and regulations. The Solar Energy Industries Association (SEA) is a trade association that provides industry information and advocacy. Home Power Magazine features online articles and forums for solar enthusiasts. Solar Reviews provides reviews and information on solar installers. Thirdly, consider these additional resources. The International Electrotechnical Commission (IC) publishes standards for solar photovoltaic systems. The National Electrical Code (NEC) provides electrical safety standards relevant to solar installations. For example, you can find the correct wire gauge for a circuit in NEC Table 310.15b16 or the requirements for disconnects in Article 690. You can find the proper overcurrent protection in Article 240. The North American Board of Certified Energy Practitioners (NABCEP) offers certifications for solar professionals. Fourthly, for those seeking formal training, several online courses and certifications are available. Solar Energy International (SEI) offers a range of solar training programs. The North American Board of Certified Energy Practitioners (NABCEP) also provides certification programs. Fifthly, specific resources are available for off-grid solar systems. Micro-hydropower explores the integration of micro-hydro systems. Off-grid solar power systems for homes focuses on off-grid applications. Off-grid electrical systems for remote homes and cabins provides guidance on designing electrical systems for remote locations. When designing and installing a whole home solar system, it is critical to understand the relevant electrical codes and safety standards. The National Electrical Code (NEC) is a primary resource for ensuring safe and compliant installations. Some examples of NEC articles and tables that are useful include NEC Article 690, which covers solar photovoltaic systems and addresses wiring methods, overcurrent protection, grounding, and disconnect requirements. Another example is NEC Article 705, which covers interconnected electric power production sources and deals with the requirements for connecting solar systems to the grid. NEC Table 310.15b16 provides ampacity ratings for conductors and helps determine the correct wire size for different circuits based on their current carrying capacity. NEC Article 250 focuses on grounding and bonding and is critical for ensuring the safety of the electrical system and preventing electrical shock hazards. NEC Article 240 covers overcurrent protection, including circuit breakers and fuses to protect the system from overloads and short circuits. NEC Article 480 addresses the installation of storage batteries, which are often used in off-grid solar systems. When sizing conductors for a solar system, several factors must be considered. Firstly, calculate the maximum current that the conductor will carry. This is based on the power output of the solar panels and the voltage of the system. Secondly, select a conductor size that is rated to carry at least 125% of the maximum current to account for continuous operation. Thirdly, consider the ambient temperature and adjust the ampacity of the conductor accordingly, as higher temperatures can reduce the conductor's current carrying capacity. Fourthly, account for voltage drop, which can occur over long distances. Use larger conductors to minimize voltage drop and ensure that equipment receives the proper voltage. When selecting overcurrent protection devices, such as circuit breakers and fuses, it is important to choose devices that are rated appropriately for the circuit. Firstly, the overcurrent protection device should have an amp rating that is no greater than the ampacity of the conductor it is protecting. Secondly, the overcurrent protection device should have an interrupting rating that is sufficient to handle the available fault current at the point of installation. Thirdly, consider the type of overcurrent protection device, such as a circuit breaker or a fuse, and choose one that is appropriate for the application. Grounding is a critical aspect of solar system safety. Firstly, ground all non-current carrying metal parts of the system, such as equipment enclosures and racking structures. Secondly, use a grounding electrode system that is compliant with the NEC. Thirdly, bond all grounding electrodes together to create a low-impedance ground path. Disconnects are required to isolate the solar system for maintenance and safety. Firstly, install a disconnect switch that can isolate the solar panels from the rest of the system. Secondly, install a disconnect switch that can isolate the inverter from the rest of the system. Thirdly, label all disconnect switches clearly and make sure they are readily accessible. The selection of components for a solar system depends on several factors, including the size of the system, the location, and the budget. Firstly, choose solar panels that are rated for the voltage and current requirements of the system. Secondly, select an inverter that is compatible with the solar panels and the grid. Thirdly, choose batteries that are appropriately sized for the energy storage needs of the system. Fourthly, select wiring and other components that are rated for the voltage, current, and environmental conditions of the system. Off-grid solar systems require careful planning and design to ensure that they can meet the energy needs of the home. Firstly, determine the energy needs of the home by calculating the average daily energy consumption. Secondly, size the solar array and battery bank to meet the energy needs of the home, taking into account factors such as solar irradiance and battery discharge depth. Thirdly, select an inverter that is appropriately sized for the system and is compatible with the battery bank. Fourthly, consider backup power options such as a generator, in case of prolonged periods of low solar irradiance. When connecting a solar system to the grid, it is important to follow all applicable codes and regulations. Firstly, obtain all necessary permits and approvals from the local utility and building department. Secondly, install a grid tie inverter that is certified to meet the requirements of the local utility. Thirdly, install a disconnect switch that can isolate the solar system from the grid. Fourthly, follow all applicable wiring and grounding requirements. Solar panels convert sunlight into electricity using the photovoltaic effect. Silicon solar cells arranged in panels absorb photons from sunlight, which then excite electrons in the silicon atoms. This excitation creates an electric current. Solar panel efficiency, measured as the percentage of sunlight converted into electricity, typically ranges from 15% to 22%. Environmental factors like temperature and shading can affect solar panel performance. Higher temperatures reduce efficiency, and shading can significantly decrease power output. There are several types of solar panels, including monocrystalline, polycrystalline, and thin film. Monocrystalline panels made from a single crystal of silicon are the most efficient and expensive. Polycrystalline panels made from multiple silicon crystals are less efficient and less expensive than monocrystalline panels. Thin film panels made from various materials are the least efficient but are flexible and can be used in diverse applications. The amount of electricity a solar panel produces depends on its wattage rating and the amount of sunlight it receives. A 300-watt solar panel, for example, can produce approximately 1.5 kilowatt-hours of electricity per day in optimal conditions. Solar inverters convert the direct current, DC, electricity produced by solar panels into alternating current, AC, electricity, which is used in homes and businesses. String inverters are the most common type of inverter and are used in systems where solar panels are connected in series. Microinverters are small inverters installed on each solar panel, which optimizes performance and allows for individual panel monitoring. Hybrid inverters combine the functions of a solar inverter and a battery inverter, allowing for energy storage and backup power. The size of the solar inverter should match the size of the solar array. A correctly sized inverter ensures optimal performance and prevents damage. Solar batteries store excess electricity generated by solar panels for later use. Lead-acid batteries are the most common and affordable type of solar battery, but they have a shorter lifespan and lower energy density compared to lithium-ion batteries. Lithium-ion batteries are more expensive but offer longer lifespans, higher energy density, and better performance. Battery capacity is measured in kilowatt-hours, and determines the amount of energy that can be stored. Battery lifespan is affected by factors such as depth of discharge and temperature. Solar charge controllers regulate the voltage and current flowing from the solar panels to the batteries, protecting the batteries from overcharging and extending the lifespan. Pulse width modulation (PWM) charge controllers are the most common type, while maximum power point tracking (MPPT) charge controllers are more efficient and can increase energy production. The charge controller should be sized according to the voltage and current of the solar array and the battery bank. Solar racking systems secure solar panels to a roof or ground. Roof-mounted racking systems are the most common type and are designed to withstand wind and snow loads. Ground-mounted racking systems are used when roof space is limited or when optimal sun exposure is desired. Pole-mounted racking systems are used to elevate solar panels above obstructions and maximize sun exposure. The racking system should be made from durable materials and be properly installed to ensure the safety and longevity of the solar system. Electrical wiring connects the various components of a solar system, including the solar panels, inverter, batteries, and charge controller. Copper conductors are the most common type of wiring used in solar systems and should be sized according to the voltage and current requirements of the system. Conduit protects the wiring from physical damage and environmental factors. Connectors and terminals are used to make secure electrical connections. All wiring and electrical components should comply with the National Electrical Code, NEC, and local electrical codes. Grounding ensures the safety of the solar system by providing a path for fault current to flow back to the source. All non-current carrying metal parts of the solar system should be grounded, including the solar panels, racking system, inverter, and batteries. Grounding electrodes, such as ground rods or ground plates, are used to connect the system to the earth. Grounding should comply with the National Electrical Code, NEC, and local electrical codes. Monitoring systems track the performance of the solar system, providing data on energy production, consumption, and battery status. Basic monitoring systems display real-time data on a screen, while advanced monitoring systems provide detailed historical data and remote access. Monitoring systems can help identify problems with the solar system and optimize performance. Permits and inspections are required for most solar system installations. Building permits ensure that the solar system complies with local building codes and safety standards. Electrical permits ensure that the electrical work is performed by a qualified electrician and complies with the National Electrical Code, NEC, and local electrical codes. Inspections are conducted by local building and electrical inspectors to verify that the solar system has been installed correctly and safely. Maintenance is essential for ensuring the long-term performance and reliability of a solar system. Solar panels should be cleaned regularly to remove dirt and debris that can reduce energy production. The racking system should be inspected periodically for corrosion and damage. Batteries should be checked regularly for proper electrolyte levels and terminal connections. The inverter should be inspected periodically for proper operation and any signs of damage. Regular maintenance can extend the lifespan of the solar system and maximize energy production. Troubleshooting involves identifying and resolving problems with the solar system. Common problems include low energy production, inverter failures, battery problems, and wiring issues. Troubleshooting may require the use of test equipment, such as a multimeter and a clamp meter. It is important to follow safety precautions when troubleshooting electrical systems. If you are not comfortable troubleshooting electrical systems, consult a qualified electrician. When working with electrical systems, always de-energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. Never work on electrical systems in wet conditions. Follow all applicable safety codes and regulations. Solar energy plays a significant role in the transition to a sustainable energy future. Solar energy is a clean and renewable source of energy that reduces reliance on fossil fuels and helps mitigate climate change. Solar energy creates jobs in the manufacturing, installation, and maintenance sectors. Solar energy can provide energy independence and reduce energy costs for homeowners and businesses. Government incentives such as tax credits and rebates can make solar energy more affordable. The cost of solar energy has decreased significantly in recent years, making it more competitive with traditional energy sources. Technological advancements are improving the efficiency and performance of solar energy systems. Energy storage technologies, such as batteries, are enabling greater use of solar energy. Smart grid technologies are integrating solar energy into the electricity grid more effectively. Policies and regulations are promoting the growth of the solar energy industry. The future of solar energy is bright, and it will play an increasingly important role in meeting the world's energy needs.